Hey, higher algebra students, today is the 12th. It is our asynchronous day. So we are going to go through a very quick lesson on lines. We're actually starting unit 4. I'm hoping to get you in and out of your math work today here pretty quick. It should come back pretty quickly. Feel free to pause and rewind this video at any point. And we will kind of just run through some reminders on writing equations for lines. So we're going to start with the daily problem. I would love it if you would pause and try this on your own and see what answer you get. You could download the notes or just try it on a scratch piece of paper. And then when you hit resume, I will go through the answer. So when we are working with absolute values, we want to take care of this stuff on the outside first. This is a callback to chapter 1. So I would start by subtracting 9, getting the stuff out of there next to the absolute value. And you'd have 3 times the absolute value of 5x minus 1 is greater than or equal to 15. I'd divide by 3. You'd get the absolute value of 5x minus 1 is greater than or equal to 5. Once we have that stuff cleared out, remember that the absolute value here is a distance away from 0. And we have 2 things that could be a distance away from 0 of 5 or more. The first one being anything that is greater than positive 5. That would be 5 or more away. And my second option would be anything that is less than negative 5. Would also be more than 5 away. So we have 2 routes here that we have to consider with these problems. And then at the end we will graph. So the first thing I'm going to do is add 1 to both sides. On my first route, I'd have 5x is greater than or equal to 6. Divide by 5. X is greater than or equal to 6/5. Same thing over here. 5x minus 1 is less than or equal to negative 4 when I add 1 to each side. Or x is less than or equal to negative 4/5. It'd be a good idea to graph this and represent this on a number line. So if you haven't done that, go ahead and try. I would probably show it something like this, where this answer here, 6/5, would be just beyond 1. I'd have a closed circle, and then I want an arrow pointing to anything greater than that. So that would be 6/5 right there. Negative 4/5 would be on just the inside of negative 1. Again, I'd have a closed circle there, and then this time I want anything less than that. So my final answer, we have an equation representation, and we also have a graph representation there. Trivia question today, goal of the day, is what year was Netflix started? And what year was Netflix started? Again, you can pause, and then I will cover the answer or go over the answer. Got 4 options for you there. Netflix was started in 1997. Seems a little early for me, but good for them, you know. Today's goal will be writing equations in slope-intercept form and point-slope form, and just reminding you of those. Don't have a ton of slides to go through. And then writing parallel and perpendicular equations and what that entails. Today's video is sponsored by Krispy Kreme. No, they're not paying me for the sponsorship, but maybe one day they'll see it and give me free donuts. That would be very ideal. Just a quick reminder on the schedule. Today we are starting Unit 4, and this will be one of 2 lessons in Unit 4. It's really short. And then next Monday we have our summative on Chapter 3, Unit 3. And then next week on Thursday, we're actually just wrapping up Unit 4 right away. Lines are a huge deal as you move forward in math. There's a lot of applications of them in future math classes, whether you're taking stats, whether you're taking pre-calc and calc, that sort of path too, which is why we want to cover them, and they'll also come up in the next couple of units for us as well. So we're going to get right into it. We're just going to talk about our first goal, and then we'll talk about parallel and perpendicular lines. Again, all just to remind you, just to get you feeling back up to speed and comfortable with graphing lines and writing equations for lines. A big thing is slope when you are working with lines. Slope is a rate of change represented by the letter m, and we say slope is rise over run. More mathematically is the change in y divided by the change of x. Always a fraction, always represent slope as a fraction. In fact, I would really stay away from decimal slopes. If you have an improper fraction, leave it as an improper fraction, because then you have your rise and your run, right? So if you find slope to be something like 7/3, if you leave it like that, that's your change in y, and that's your change in x. Slopes, another very common mistake is that we read them left to right. All slopes are like a book, right? We read them left to right. Any positive slope is going to go up from left to right. Any negative slope is going to go down from left to right. I think of a skier or like a sledder. Skiers would like negative slopes more, because as they ride down them left to right, it's going to be a lot nicer for them. So yeah, that is slope, and like I said, we represent them as fractions, as rise over run. So the first type of equation that we're going to start with is probably the most common, slope-intercept form, and that is y is equal to mx plus b. So you see the m in there as slope, and then b is going to be where this guy crosses the y-axis. The y-intercept, x is always equal to 0, so you're always going to find your y-intercept along this axis. So in this graph, it looks like my y-intercept would be 0, 1, and this one is pretty close to 0, 3, maybe 2.5 would be better. So you might see a question that looks like this. Write an equation, and then you are given this information. You say, well, I have a slope, I have an intercept, so I'm going to use slope-intercept form. So this one, y equals mx plus b. Just plug in what you know. Slope is 1/2. Your intercept is 7. Just like that. If it were like -8 for your intercept instead, like 0, -8, you could just change that plus to a minus. You pretty commonly see it written as just like -8. The other equation we want to remind you of is point-slope form. And notice how we are subtracting both of these. So if I have a point y1, oh, that's switched around, sorry about that. x1, y1 is how points are written. Even if these are positive, or I guess if they are positive, we write them as subtracting in here. And notice again how m, your slope, just is kind of chilling there next to it. So we're always going to subtract our points in point-slope form. So if I look at this guy, and I wanted to write an equation, m times x minus x1, I would throw my slope in right there as -3/4. And then x minus x1, that'd be x minus this +2. And then y minus y1 would be y minus -1. But we could clean that up a little bit and make that y plus 1. So the big thing with point slope is you are given just any point on your line, not necessarily the y-intercept, and we are going to subtract them. So really make them the opposite sign. So 2 becomes -2, -1 becomes y plus 1. So that's all that we're really going to be talking about writing equations. Next time we'll be talking about looking them on a graph and graphing them when we have a little bit of a longer class. The next thing we need to talk about is parallel and perpendicular slopes. So here are some examples of parallel slopes. Maybe you see a pattern going on here, but the biggest thing is that if we want lines to never touch, they need to be moving at the same rate, right? They need to have the same rise and the same run. So anytime that this guy goes up 3/1, the red guy does, I need my blue to do the exact same thing so they never crash into each other, right? Anytime this goes up 3/1, this one also needs to go up 3/1. These both have a -1 slope, and these both have no slope at all. giving them the same slope, meaning they'll never crash into each other. So you might be asked, what would a parallel line be to this? And really the only thing that we need to pay attention to is that they have the same exact slope. So let's say, find the slope of a parallel line and then write an equation with an intercept of 0, 11. I'm going to add to this a little bit. You would say, okay, well, I'm going to be in y equals mx plus b then. My m needs to be the exact same, -1/2, right? Because there's point slope form. There's my slope. And then the new intercept that they give us is plus 11. So you might see some questions like that. If parallel slopes are the exact same here, perpendicular slopes are going to be the exact opposite. So if you start with 2 as your slope, the exact opposite of 2 would be make it negative, and then reciprocal. Flip it around. Same thing here. If my slope starts at 2/3, if I want it to be perpendicular, right, make a 90-degree angle here, I'm going to make it the exact opposite. So I'm going to make it negative, and then flip it around. This one started as -5/1, right? We can divide by 1. I'm going to make it the opposite sign, and then flip it around. So -1 would become 1/5 x. So if you were asked, like, write a new equation that is perpendicular, and let's say it goes through like 3,8 or something like that, you would say, okay, well, I need this form. My slope started at -2, so I'm going to turn that over, and then I'm going to go from a negative to a positive. So my slope's going to be +1/2 here. And then I'm just going to plug in the point that I need to work with. So y minus y1 would be y minus 8, and then x minus x1 would be x minus 3. So a perpendicular to this line that goes through 3,8 would have this equation up here. One trick that you could use with perpendicular lines is they should multiply to -1. So if you start with 3/4, if you change it to +4/3, if you multiply those, you'd have -12/12, which is a form of -1. This guy here, 1/3, perpendicular slope to 1/3 would be -3/1, right? Flip it, make it opposite, the opposite reciprocal. That would be -3/3 if I multiply it, which is also equal to -1. So last slide here, and again, these are very similar to the ones we just went through. The first one says write an equation for a line parallel to this one, and it goes through a point. We're not given an intercept, so we're going to have to use point slope form, x minus x1. I need the parallel slope, so that slope is going to stay the exact same, 5/6. And then here's the point that I'm going to use. So y minus y1 would be my minus 8 again. And then x minus x1 would be x minus -1, so x plus 1. That would be an equation in point slope form that is parallel to this given equation. Last example here, if I want a perpendicular, and now I have a y-intercept, I have to look at this guy and say, okay, here's my slope. So if my slope starts as 4/1, I'm going to change it to -1/4. So there's my new slope, -1/4. And then my new intercept is going to be 2. So because they gave me an intercept and a slope, I'm going to use slope-intercept form. And my final equation would be y is equal to -1/4 x plus 2. So again, just to recap, focusing in on slope, focusing in on intercepts, and then maybe even writing a few point slope equations. There is a homework quiz online. It should be pretty quick. If you have any questions, feel free to reach out to me on Schoology. I will be around my computer all day today, and let me know how I can help you, and then make sure that you have a very good weekend.